Welcome to a Spiral Back Review. Today we'll be working with an 8th grade question. This is number 2 of 5 questions for review. So we're going to go ahead and look at this one. This one says to consider the equation 3x minus 2 equals 3x minus 2. So as we know, this is distribution property. I'm going to put little arrows for myself so I don't forget. Determine whether the equation has one solution, no solution, or infinite amount, and use words and or symbols to justify. Now, I'm going to come over here and just write a little note for myself. I remember that if it has one solution, basically you get x equals a number, and all that means is it intersects in one spot. So 2 lines intersecting in one spot. Looks to me like they have different slopes, different y-intercepts. Then I'm going to go down, and if I end up getting parallel lines, they never intersect. So there's never a solution. There's no solution there. And of course, if I get the same line, 2 sides of the exact mirror image of each other, the picture of each other, then I would get infinite amount or all real solutions. So those are some things to think about as I work through. Those things caught my mind as I read this. All right, so I'm going to use distribution property, and I'm going to get 3x minus 6 equals 3x minus 2. I'm going to go ahead and solve. I'm going to subtract 3x from both sides. Oh, they cancel each other out. I'm left with negative 6 equals negative 2. Kind of like looks strange to me, right? So I'm going to keep on going if I choose to. I may get down to negative 4 equals 0. Well, neither of these two equalities are true. So neither are true. So neither of the last 2 equalities are true. True, so hard to write with this pen. Sorry if that doesn't look like equalities there. So there's no solution. So basically it's over here. These will never cross. So there's no solution that will work. I could take days and plug numbers in and substitute numbers in for x, and I will never get an answer, and I'll never get a true equality. So I'm going to come down to part B, and it says create a linear equation that has one solution. Okay, so now I know that basically my slopes have to be different. So I get an intersection point. So I could come up with anything, and you may choose something different. I'm just, for fun here, going to see what 4x plus 7, let that equal 5x minus 3. Kind of made all my numbers different. So I'm going to go ahead and solve. I'm going to add 3. 4x plus 10 equals 5x. Subtract 4x. So 10 equals x. That looks like there's one solution. So that's probably quite a great equation. X is on both sides, so I satisfied the criteria of the question. Okay, and I'm going to go back. I like to make sure that my equalities are true. So if I put in 10 here, 4 times 10 is 40. 40 plus 7 is 47. Put in 10 here. 5 times 10 is 50. 50 minus 3 is 47. So this one solution gave me a true equality. So it looks pretty. All right, you ready to try one on your own? Oh, solve your equation. We already did that, so that's kind of good. So we can go ahead and move on. So there were 3 parts. Of course, if I was going to give this to my teacher, I might go ahead and just try that again. That was a good chance for me to see if it worked. I'm going to go through it again and add 3. Again, you may have chose to move the 4x first. So 4x plus 10 equals 5x. Subtract 4x. Subtract 4x. And 10 equals x. And I'd want to put my answer right on that line. Always good to put your answers on that line. All right, good job. Now I think you're ready to try one on your own. Here's part A. I'm going to show you both parts, and then you can rewind the video and move on. All right, so I'm going to show you the parts of it. So here's part A. You're going to solve that equation. And here's part B. You're going to explain how you know the equation in one variable has infinite many solutions. So what does that mean? And what does it mean when the linear equation in one variable has infinitely many solutions? So one, it says explain how you know when one does, and then what does it mean when one does? Okay, so just rewind back if you're doing this as a video. Have a good day.